Number 8 then, the last question in paper 1 of the 2025 Advanced Term Maths. So this should be presumably the hardest of all the questions there. Well, here's the equation of three planes, and you have to use Gaussian elimination to find t, the point of intersection of them. Well, that just means solve those simultaneous equations there. But you have to solve them a particular way. You have to solve them by using Gaussian elimination, which means you make up an augmented matrix of the matrix of coefficients and the matrix of the solutions. So the coefficients are negative 1, 1, 4, 2, 3, 1, 3, 2, negative 2. Augment, there's the join. Negative 6, 15, 16. So that's the augmented matrix. And Gaussian elimination means reduce this to upper triangular form. I want those to turn into zeros by adding these in pairs, by using linear combinations of them, so that that turns into 0, that turns into 0, and that turns into 0, thereby isolating the z so I can find it. We'll leave the first one alone. That's actually ideal because look at it. Starts with a 1. Right, this one. So what happens to row 2? Well, if I take row 2 and subtract from it 2 lots of row 1, you could write row 2 goes to if you like, but obviously applies to row 2 here. So that'll be 2 take away 2 is 0, which is no surprise because that was your plan. Then we've got 3 but plus 2, which is 5. And then 1 minus double that is 8, which is negative 7. And then 15 but plus 12. So that will give you 27. Right, row 3 minus 3 of them would do nicely, because that obviously gives you a 0. So I've got 2 but plus 3 is 5. You just have to be careful of all the arithmetic. And you've got negative 2 but take away 12, so that's a negative 14. And then you've got 16 but plus an 18, so that'll be 34. Right, almost there. Happy with that. Happy with that. Starts with a 0. I want that to start with 2 zeros. So the plan now will be row 3 take away row 2 to produce the new row 3. So 0, that was handy because that's 0. Negative 14 plus the 7, so negative 7, and that's a positive 7. Now that you've done this, you've isolated them. There's the z equation. There's the y plus z equation, which you can find once you've found that, etc. So the first equation, negative 7, z equals 7, so z equals negative 1. Step up to this. 5 times y, I don't know that, minus 7 times, but I know that's negative 1, should equal 27. So 5 times y, now that's a 7, take it across, leaves a 20, divided by the 5 is a 4, and then finally up to the top, x take away, now the y was a 4, plus 4 times, now the z was a minus 1, should equal negative 6. So you've got minus 4 is minus 8. You bring that across and you get a 2. And it said, what does it say here? Find t, so I'll have to state what t is. I'm not letting myself room here, so I'll just put it here. So t is the point, x was 2, y was 4, and z was negative 1. And part B, you've got this line 1, which has this equation in symmetric form, and you have to find the point of intersection B of this line with plane pi 3. Well, if that's the equation, they're all equal to each other. In particular, they're all equal to the parameter. I can rewrite that in parametric form by taking these parts. So x will equal the 3 across, 3t minus 4. Y will equal, take the 2 across, 2t but plus 7. And z will equal 1 times it is t plus 4. So there's the parametric equations. Now just put them into this. So for L1 intersect pi 3, just make sure you use the right bits and pieces. I'll have this. I'll have 3 of x. So I'll have 3 of 3t minus 4. 2 of y, I'll have 2 of t plus 7 minus 2 of z, that's 2 of t plus 4, and that lot should come to 16. So from this equation you can find the value of t. That's the parameter that steps you along in units of this position vector of the line, not position, direction vector of the line, 3, 2, 1. But anyway, it's just a little equation. I can multiply it out. So 9t minus the 12, 4t plus 14 minus 2t minus 8 should equal 16. I just gather it up carefully. So you've got 9 and 4, take away the 2, that's 11t. That's nasty because you don't want fractions for your parameter. But then if that turns out to be a multiple of 11, that's fine. And then we've got minus 20, so it's minus 6, that makes 22, so there you go. All's well that ends well. Divide that by 11, 2. So it's the point with parameter t equals 2. So now you can go back and find what they are. So x is going to be 3 2's, take away 4. So that'll be 6 take away 4 is 2. Y will be 2 2's, add 7, so that's 4 and 7 is 11. And z will be 2, well, I'll put in a wee bracket anyway, so it keeps company with them, plus the 4, which is 6. However, it didn't just ask you for that, it said, was it p? Find p, the point of intersection, so I'm now going to put it together. P is the point 2, 11, 6. And then part C, it says, find in parametric form, that's the same form that you put it into the equation of the plane to find the point of intersection, find in parametric form the equation of this line L2, which passes through the points rather, T and P. So it goes through T and P. Well, that's it. Well, if you want the equation of a line, you just need two things. A point on it, pick either of them, and a direction to go in. And then you can step off in that direction to find all the other points in the line. So I'll need its direction, whatever you want to call it. You can give it a name there, or you can just say, essentially, I just want to know what's the vector that goes from T to P, point T to point P, because that's the vector for the line. Well, you could use your position vectors, but you could read it just from this. If you go from 2 to 2, that's 0. If you go from 4 to 11, that's 7. If you go from -1 to 6, that's 7. So there's the direction vector of the line. Which means that for this line then, however you want to put it down, r equals using the general position vector, or you can just say x, y, z, being any point on the line, will be found by starting at a particular point, say I start with 2, 4, -1, and take steps of this, 0, 7, 7. Every time you take a step of that, you'll arrive at another point in the line. Of course, those are discrete points, but t can be any number. Now just spell that out separately. That's the vector equation. So the parametric equation would be just read it line by line, the top one first of all. So x is going to be, now there's no t's, x will just be 2. Now that means this line L2, lies on the plane x equals 2. So it's parallel to the z-y plane. But it doesn't ask you to say any of that. X equals 2. Y is 7t plus the 4. And z is again 7t, but -1. Those are the parametric equations.